Carlos Castillo is a very well-known researcher in the field. His main research activities are related to how how computing in general, computing technologies affect our life, society life. He wrote also a book recently on these topics. He's leading an active research group at Pompeu Fabra in Barcelona, and we asked him to address a topic that is an example of interdisciplinarity between IR, information science, and data science, because the issues of fairness and transparency requires a rigorous scientific use of data to address specific user requirements and problems related to bias, fairness, transparency, and accountability. Indeed, Carlos chaired this year in February, January, the last ACM conference on fairness, accountability, and transparency. So he is one of the major experts in the topic. So I thank Carlos, and I'm giving him the space to speak to us. And thank you very much again, Carlos.
Thanks, Massimo. I hope you can hear me now correctly. And you can see a slide titled Fairness and Transparency in Rankings, and now a slide titled Contents. Is it okay?
Yes.
Okay, perfect. So thanks for inviting me to this workshop. I think it's a very interesting topic for in the framework that we have heard, because this is a topic that started in the data mining community and then moved into the machine learning community, and then it's starting to be tackled more by the information retrieval and the NLP communities and so on. And also it has some interdisciplinary elements that we will discuss in a moment. I don't think I will go through all the slides, but I have shared in the chat window the slide deck for everyone, so that you can see the rest of the materials that I may have to skip. So the first question is whether this talk is about algorithmic bias, and a question that it's very important here is whether algorithms can discriminate. Right? So can algorithms discriminate? So let's go back to some traditional definition of what discrimination is. So discrimination is something we do every day, and in general, discrimination is simply to treat someone different from somebody else because they have a certain property. So discrimination in general is a disadvantageous differential treatment, and it's not per se a bad thing. So when we open a position for a job, for instance, we do discriminate between candidates that we believe will be efficient or will give us like value in this job, and candidates that perhaps will give us less. So there is nothing inherently wrong in treating someone differently from another because they have a certain characteristic. However, things start to get more complicated when, and there is an issue when you speak about group discrimination. And group discrimination is treating someone differently because they have a characteristic, and this characteristic is being a member of a socially salient group. So this characteristic is not necessarily their capacity to perform a task, but this characteristic is being a member of a socially salient group, which is a group that is very visible to people and that plays an important role in the relationships of a person with others, particularly with respect to relationships of power. And then a particular form of group discrimination described in moral philosophy is the statistical discrimination. And statistical discrimination is group discrimination that is based on a statistical fact or a statistically relevant fact, right? So you have a person who is treating somebody else in a worse manner with respect to another person because this person belongs to a socially salient group, and the person who is discriminating has statistical evidence to believe that that causes this differential treatment. So let me give you an example of what do we mean by statistical and non-statistical discrimination. So if you are a hiring manager and decide not to hire a highly qualified woman because you believe that women have a higher likelihood of asking for parental leave, then you are engaged in a statistical discrimination. You're using a statistical fact or a statistical belief to treat this person worse than another. However, if this person tells you upfront that they intend to take parental leave, then there will be non-statistical discrimination. You're basing your decision on a fact. So in a statistical machine learning, which applies to information retrieval system based on learning to rank, or in machine learning, which are, I would say, most like deployed large-scale systems, if we disregard this idea that there may be some animosity, and we understand that everything that a learning to rank or a machine learning system picks from a data is statistically relevant for the purposes of a task, then we can say that algorithms discriminate, right? So, and in this narrow sense is where we speak of algorithmic discrimination. So algorithmic discrimination is a form of a statistical discrimination, which is a form of group discrimination. So let's talk briefly about why this is important in information retrieval, right? So typically the objective in the search task of information retrieval, which is the most fundamental task, is to provide the maximum relevance to the person who is issuing this search. So what we do is that we try to sort documents by decreasing probability of being relevant to the person who is issuing a search. However, more recently, we are starting to sort not only books and documents and web pages, but we are starting to sort other objects that have their own interests, right? So the utility is not only now the utility for the person who is issuing the search. The utility is also the utility for that we care about is the utility for the objects that are being searched. So if you're looking to find a local business, then your search engine may be determining the success of comparative success of different business, or if you want to purchase a product, then the marketing success of this product, and even when like you may not necessarily see them as information retrieval system, it's more like a recommender system, but it still is an information access system. A dating app is indeed and it runs an algorithm that may affect the affective success, the reproductive success of certain groups in a different manner, right? So there is an increasing concern about from the well-being to the utility to the interests, caring about the interests of these objects that are being searched, which are no longer just books, right? So we need to, that requires establishing some criteria of what will be algorithmically fair, right? So, and I propose these three. So like, like you can think that fairness to the elements that are being searched means first that they are present, like they are present in sufficient numbers so that they do not suffer allocative economical harms, right? They are not pushed down or in the ranking, they don't disappear from the ranking, they still have a choice of a chance of being selected by the user who issues the search. We also want a consistent treatment for objects. So in the sense that objects that have a similar relevance should be ranked similarly. And this sometimes conflicts with the first characteristic or the first objective. And third, we would like also a proper representation of the protected group. So we would like to represent them properly. I will unpack this in a moment. So there is also there are also some works that deal with the algorithmic fairness in ranking for the people who are issuing the search, and this has to do with them having an equal level of satisfaction. So as we see this thing of designing a good search algorithm is becoming much more complicated, because now we not only want to satisfy users, but we want ideally to satisfy different groups of users equally, which is not the case if your training data or if your evaluation is based on the desires or the goals of a particular segment of the population, right? So typically, if you design a search engine or any application having in mind a particular sector of the population, then you may not serve very well their other sectors, right? So I spoke about representation and harm. Let me tell you what it means. So representation and harm are ways in which a search engine may work, or a computational system may work, that reinforce subordination of certain groups to others, right? So in the particular case of search engine, There is an entire book about this, like it's called Algorithms of Oppression, and it's based on the observation that in general, if you look for race women, like Japanese women, German women, Italian women, you may see very highly sexualized results, which is very different than if you search for Italian men or Chilean men or Japanese men, right? And there are also very stereotypical search suggestions. Indeed, Google in these days basically blacklists almost anything that is a completion of the phrase nationality are. So it's very difficult to find a query such as like Germans are, Italians are, Chinese are suggested by Google. So they sort of, in many of these cases, they gave up. They said, no, there is nothing we can suggest you based on what our users search that we don't find offensive, right? So with respect to representation, with allocative harms or economical harms. So the issue is perhaps like it has to do with how do you translate notions of representation in a set to notions of representation in a ranking. And I'm going to come back to this later in the talk. But so for instance, we are showing 3 different searches done in a search engine where you are trying to look for candidates for a job, right? So suppose you're looking for an economist. Then the first economist return is a woman, and economists from the 2nd to the 10th are men, right? So if you look at the top 10 results, there are 90% male and 10% female. But if you go deeper down this list and you look at the top 40 results, then indeed you find roughly 27, like a third of the candidates are women, right? So in a sense, what we see here is that there is an exaggeration of a difference that already exists in the data that happens when you look at the top places. And this is quite common. This is a quite common source of concern for people who work on algorithmic bias. The fact that systems tend to reinforce certain pre-existing biases in the data. Another question that is important here is whether, okay, you can say is one economist in 10 that is a woman, but is in position number 1. So perhaps somebody can say, well, position number 1 is not the same as position number 10. How are you going to weigh different positions, which is another thing I will try to address later on. So in general, like in rankings, we may be facing 2 completely different goals. So one is to reduce discrimination, and the other is to provide equal opportunity. And these may sound very similar, but are actually quite different, right? So in some cases, you may have a group that has higher utility and lower rankings. And this is something we have observed in our research on university admissions. So we have seen that the systems for university admissions that are based on standardized tests, they tend to favor applicants from economically privileged backgrounds in contrast to applicants of other backgrounds, right? So this will not be surprising in the sense that you may expect that someone who can pay for a better education, a family that can pay for a better education for the children can expect them to score higher in a standardized test. But the problem is that if you admit indeed the students from a lower economic background that score perhaps a little bit lower, then actually those students may have a higher chance of finishing the university studies and finishing with better grades. So in a sense, the test is being discriminatory in the sense that it's not selecting the candidates that are most likely to finish university or to finish with high degrees. It's picking the candidates that have a higher scores in the standardized test, which is heavily biased towards candidates of privileged economic background. So that's reducing discrimination, and it's somehow a very easy sell when you are designing a computer system to try to reduce discrimination, because you can improve things for everyone. You can improve things for the candidates, and you can improve things for the people running the system. However, in other cases, you want to provide equal opportunity. And equal opportunity means you have a group that has a lower ranking, but actually that group provides you a lower utility. So you may have a particular group of students, again, in the university admission case, who do score lower in the standardized test and also have a smaller chance of finishing university. But you may believe that the system has treated them unfairly, and you want to kind of level the playing field back again, and you want to provide them equal opportunity here at the admittance to the university. That's a much difficult thing to sell but actually there are many systems that try to provide this thing. And perhaps one of my main take home messages today is that you have to know what you're trying to do. Where are you trying to reduce discrimination, which means improve utility for the candidates and for the system, or are you trying to correct an imbalance and actually improve the utility for the candidates, even if you harm a little bit the utility for the system or for the people who are searching? So there is a lot of data science work that goes into trying to design a fair ranking system. And most of this work I will characterize as trying to find biases in the input data, right? So you have biases in the expert provided training data. So if you have annotations of quality used to train a learning to rank system, then these editorial rankings may first perhaps be selecting from a limited pool of candidates or documents, which will be problematic, or maybe your expert annotators are biased. Second, the users also have biases, and they may prefer certain things with respect to others. So for instance, Google Ads have been criticized in the past because they were serving less high-paying job ads to women. And of course, like the conjecture is that they were doing so because women will click less on those ads. So again, they will have a system that is taking a pre-existing bias and exaggerating it and creating a feedback loop. So you have biases in your user-provided training data, and you may have racist users, and you may not want to have a racist system. And third, there are biases in the document construction itself. So for instance, there are subtle differences across genders that have been observed in the completion of LinkedIn profiles. So in LinkedIn profiles, there is like a small tendency of women to be more detailed in the skills sections of their profile, while men will be more detailed in their past experience section of their profile. Of course, in many cases they are equal, but there are some cases in which the documents are different. And if you have different documents, then whatever information retrieval system that you build on top of that is supposed to take these documents and rank them together will have to face that it is designed for perhaps one majority set of documents and not the minority. There are many ways of measuring this ranking. So let me describe a couple of them like very quickly. So first, there are two important notions in data mining, like classical algorithmic fairness notions, classical in the sense that they are 15-year-old or something, that like statistical parity, right? So statistical parity basically means that when a system selects a set, then that set should contain equal amounts of protected and non-protected elements, or of minority, majority element, men, women, black, white, etc. Right? So and in the sense of rankings, you can also fix a value of k and consider the top k as a set. And there is a different notion which is called equality of opportunity, and it's technically described, so it has a very specific meaning, equality of opportunity in the algorithmic fairness community, and it basically means equal error rates, right? In particular, typically it's used, true positive rate is used for that, right? So it means that the number of elements, if you return, in the case of rankings, if you return to a user a set of elements, then the elements that are relevant for the user include and belonging to different groups should be the same amount of elements, right? So that would be the equality opportunity translated here. But it's basically an equality in terms of error rates. So there are other methods to look at ranking. So again, if you look now this long existing like observation about how people navigate information systems, and you can see that they have a certain preference for elements that are at the top, elements that are on the left, depending if they read left to right, and so on. And what you want is that you want to equalize the exposure that is given to different groups, right? You want, and this is important because small differences in utility or computed utility or predicted utility, inferred utility, cause big differences in exposure. So suppose here you have 6 candidates, and for some reason the 3 men have obtained like tiny, have been predicted to be slightly more relevant than the 3 women for this particular search. So the difference in relevance, which are the blue bars, is tiny, right? However, given that the exposure of different positions is heavily discounted and many users don't bother to look at the third, fourth, fifth position, then a small difference in relevance is translated into a huge difference in exposure, right? Again, another case of a computer system taking a pre-existing difference and exaggerating it and creating perhaps a feedback loop. There are other measures that are more defined in terms of probability, right? So they assume that fairly mixing two lists, like fairly mixing a list of top men candidates and top women candidates implies a random process. And in this random process, you will take elements from the protected group with a certain probability. If that probability is 0, then you will take every element from the privileged group and put them all above the protected group or the unprivileged group, right? If this probability is 0.5, then, well, this could be one outcome that you actually intermingle both lists. And there are statistical tests that you can do to test different rankings and to see if they comply with this condition, that they represent a group as if the elements from that group would have been picked at random. I will give you just the main element of these methods, is that the main challenge of these methods is that you don't necessarily know. You cannot necessarily translate this into a set because you don't know when the user is going to stop, right? So there you may have to produce a fair ranking, which should produce a fair set of candidates for a variety of users, some of which will examine 3 candidates, while others will examine 5, while others will examine 20, right? So the idea is that all of these, the person who examined 3 candidates, 5 or 20, they observe a set that has a sufficient mixture of elements from both groups. So what you do basically here is that you apply a statistical test to every prefix of the list, so every prefix of the list, so that you have so that you are sure that you comply with this set no matter when the user stops. And the problem with this is of course that you're doing many statistical tests, and if you do many statistical tests, then you increase the chances of rejecting a fair ranking. So you need to adjust this. Okay, this is more detailed. But this can be applied, and one application is that you can compare different lists of different lengths with gaps and so on, and try to come up with a kind of a unified measure that tells you how well a group is represented in a ranking. And here there is an application to job search. So we compare several countries, but here are 3: Spain, France, and the United Kingdom. And we issue the same query in different languages, like in Spanish, in French, and in English, and in 2 different job search engines, LinkedIn and Viadeo. So we look for lawyers in Spain, France, UK. We look for cooks, we look for dentists, and so on. And we observe many things. First, that there is a huge difference of the presence of, and these numbers, like, sorry, the red means a small presence of women, and the green means a large presence of women, right? And what we observe is that in Spain, if you look for a scientist in LinkedIn, you will see the equivalent of women that as if they were about 10% of the data. If you use another search engine like Viadeo, you will find 30%. If you look it in France, then you may find a 70% or 80%. And this varies heavily across countries. More worryingly, it varies between search engines in the same country. So there is an extra element, and those of you who come from who speak languages that have a gender for these professions, right? If you speak German, Italian, French, you know that there are 2 different words to refer to a professional in this job that is a man or a woman, and supposedly in all our languages, by coincidence, of course not by coincidence, the male is the neutral. So if I search for the profession in male, I am supposed to be referring to men and women. However, these search engines don't interpret things like that. And in some professions, you need to use both words. For instance, the word for teacher is profesor, and for a man, and profesora for a woman. Then you may have to search for professor or profesora if you want to see a mixture of men and women. However, in other professions, it's sufficient to search for the men. So this is inconsistent within the same search engine. There is an inconsistent usage of the male the neutral pronoun for men, right? In some cases it means men, in other cases it means it's neutral, and depending on the profession, it's different, right? So it's completely inconsistent. So let me try to wrap up like in 5 minutes. So I'm going to keep the part about creating a fair ranking, where perhaps something interesting is that there was a session on Monday at CIR where they will presenting some of these papers, so you can look them up in the slides that I have shared with you. Like you can see that there is a control and fairness and bias and dynamic ranking, which is a learning to rank process based on click stream. So you get feedback from users, but you have to take into account both that the clicks from users are biased by position, and second, that the clicks of the users may be biased towards a certain groups or against a certain group. So they present a method to try to control that bias that is coming from the users and still produce a list that fairly represents different groups, right? So let me try to finish like 5 minutes with a part on transparency, right? So there is a huge discussion about transparency in ranking, which is taking place, right? So we would like to have rankings in which we are able to test, in which we can support ethics compliance, in which we can debug these rankings, and so on, right? So we would like transparency in these rankings, which is a huge thing to us because nowadays we don't have this transparency. So we would like to present to kind of the way in which we would like to operationalize this transparency is by providing explanations, and there will be some talk later today about explanations, right? So explanations tend to be contrastive, and sure, to me, and I would say the standard for an explanation in a ranking is that explanation should be enough to empower a user to challenge the ranking. So it's not just that the user can understand the explanation, it's that the user can take this explanation and do something with it. And that something will be create a case, like a compelling case, based on evidence, and use this explanation as evidence that your ranking has ranked them unfairly, like unfairly low, or have excluded them from the top positions, right? So transparency in rankings is important, and in general information systems is important because of advertising. And somehow, like since in the last I would say 10 years, transparency in ranking has become transparent, right? So it has become some sort of more opaque, right? So it used to be the case, if you remember Google around 2010, 2011, that the results that were paid, the sponsored search results, were shown with a background of color. At the top of the results, as always they have been, but with a background of color. And today they have like a tiny sign that says ad, and they blend more with the ranking. So if they may, of course, you can say technically they are indeed telling you that that result is sponsored, but the way in which they are telling you this is not sufficiently salient for you to realize that this is the case. And of course, you have to have Donald Trump here. So Donald Trump has these tweets, if you remember, a couple of years ago, where he was saying, well, Google search results for Trump news shows only liberal media, but I would like it to show conservative media. Why Google is favoring liberal media over conservative media, or progressive media over conservative media? And the problem with this sort of statement is that we have no way of contradicting Trump. So there is no way with the tools we have today of proving him wrong, because we don't know. Like how could we tell? How could we tell if Google were or not let's say, promoting liberal media over conservative media? So this is a very tricky question, because it's posed in a way that really cannot be challenged. It cannot be challenged, right? So the only way in which such a statement can be challenged, I would say, in a convincing manner, is through auditing. Right, so just like a big corporation have to experience financial auditing, in some cases algorithms should also be audited, particularly algorithms in the public sector, or algorithms that have this level of relevance. And auditing is a standard practice in finance. It doesn't need to violate like business secrets or anything, and it's just like observing, like auditing internally by an external auditor, whether these systems are indeed favoring or not a group over another. And there is a great book by Frank Pasquale on the black box society, and he speaks about how algorithms are hidden behind layers and layers of opacity, right? So there is another reason why transparency is very important in algorithmic rankings, which is personalization. And personalization plays a role in the following sense. So there is a very good example in Twitter and Tear Gas, this book by Zeynep Tufekci, and she says, well, if you go and see out of your window a big demonstration, but you don't see it on national TV, then you can say, well, the TV is hiding something. But if you turn off the TV and the newspaper and everything, all the news you get are through algorithmic feeds, then how could you tell whether the fact that you are not seeing this demonstration is because it is algorithmically irrelevant for you, or whether it is actually being hidden on purpose, right? And there is no way you can tell that. So there is no way to measure the coverage of such news, right? While in a more traditional legacy mediascape, you could do it. So there are a couple of proposals, and there are more, but I will single out a couple of proposals for making rankings more transparent, right? So one, and this happens not only in ranking, but I would say in other areas of algorithms, this idea of kind of a nutritional label, right? So, and I like this because a nutritional label is something quite complex, right? So I'm not supposed to know what magnesium is or what it does to my body, but somehow nutritional labels educate me in the fact that this thing contains magnesium in a certain amount, that I'm supposed to take this much every day, right? So, and they are simplified, friendly, standardized, and accompanied by education programs that help me understand what I'm eating, right? And here is a similar thing. So the idea is, well, you take your ranking, and maybe you need to explain what are the ingredients of this ranking. So what are the attributes that play a role into creating this ranking or this recommendation or whatever, right? You need to explain what is the diversity of this ranking, whether it passes or not certain algorithmic tests of ranking, and so on. So you may have like a nutritional label, right? An explanation, a standardized explanation of rankings, right? And there are other things that are more, I mean, there is, of course, this is a very complicated thing to achieve in practice, because what you may think is a good idea may not be a good idea in the end. So for instance, suppose you have this very simple ranking algorithm that uses a linear scoring function, right? So the scoring is 0.2 times the first attribute, 0.3 times the second attribute, 0.5 times the third attribute, right? X0, X1, X2. And then you take the attributes of a document, you compute this linear function, and you get a score. And this score induces this ranking. So D0 goes first with a score of 1, D1 goes second with a score of 0.75, D2 goes third with a score of 0.55. Now, if you want to offer an explanation of why this ranking is D0, D1, D2, you may be tempted to say, well, feature X2 has the highest weight, so that will be my explanation. So the ranking is like this, and you cannot mention all 200, 300 features that you're using for ranking. You have to pick a few. So you will be tempted to say, well, perhaps I will take the highest weight feature. The problem is that if you change that feature value, you don't change the ranking. So you may have to offer as an explanation another feature that if you change it, you will change the ranking, right? So a perturbation-based approach to explaining a ranking. And there are of course, other approaches. So let me finish by saying that this came from data mining and machine learning, and is slowly being more relevant for information retrieval, recommender system researchers, and now information systems and other. Sometimes it's about the algorithm. Sometimes it's about the broader context in which an algorithm operates, right? So you can have algorithms that pass all the algorithmic fairness tests, but that are deeply unfair. And the other thing is that all of these methodologies, many of these, basically I would say all of the metrics for algorithmic fairness can be cooked. So you can change the outcomes of the algorithm in a way that makes you pass this algorithmic fairness test, but actually is unfair, right? So you need to have a like in mind that it's not just about the algorithm, and also there is another element that I would call is like you need to know what is the problem you're trying to solve. So are you trying to improve utility for everyone in this information system, or are you trying to provide equal opportunity to the people who are being searched or who are being surfaced through this information system, right? And I will leave you some work, like there are some mechanisms for affirmative action, residual prediction, and other ongoing work. Yes, that's my presentation. Thank you very much.
Thank you very much, Carlos. We have time for a few questions. So if somebody wants to ask for questions, can I don't know if you can raise your hands or just directly talk. Does anybody want?
Hi, it's Graham from University of Glasgow. Sorry, I don't know how to raise the hands, but thanks, Carlos. That was a very interesting and detailed talk. You said a number of times through the talk, things like you have to know what you're doing and you have to pick your particular measure and stuff. I was just wondering if you could give us your thoughts on, do you think it's desirable or possible to sort of work towards a unified sort of notion of fairness? Because obviously choosing which type of fairness that you're wanting to actually implement in itself could potentially introduce biases. And I was just wondering, you know, what's the sort of broader perspective within other communities as well as to whether or not this is possible, desirable, and if we need to involve sort of other communities, potentially social scientists or whatever, to sort of develop a more unified notion of fairness that people can agree on.
So I think so. Information retrieval is like I think it's a field that is really interesting because it has spent a lot of effort in evaluation. So there, even you could say that information retrieval evaluation itself is like a very kind of well-defined discipline, and you can make an entire career information retrieval evaluation only, and as the community has worked a lot on it, and so I would say that here this is perhaps even more complicated than relevance. So it's more complicated to define, and it may require perhaps, and here my opinion would be that it will be, in some sense the community is sort of arriving to a few metrics that take to appear over and over again, like statistical parity and equality of opportunity as kind of basic metrics for comparing different systems. But I don't think it will be a single metric in there, it will be a set of metrics. But also I think it has to do with the process, right? So this is like one way in which you can see algorithmic fairness is like as an issue of quality of a system, and to ensure that it has this quality property, like being algorithmically fair, you need a process that guarantees that kind of fairness, so that ensure that sort of fairness. And transparency is part of this process, and evaluation is part of that process. So to answer another question that is about if I have a fair algorithm but not transparency, I would say, thinking in the broader perspective, as Graham is suggesting, you will need to define what is a process like that. What is a process that helps you arrive to a ranking system that is not discriminating, right? So I would say just to having like trying to coalesce around a small set of metrics, and just to trying to perhaps design like have processes that involve from the data collection to the evaluation to the metrics to the transparency, that allow you to create an algorithmically fair system, similarly to how evaluation of rankings work, right? So when you go to TREC or another evaluation a conference is not only like the testing set what that matters, right? There is a whole process that arrive to that testing, to that set of to that evaluation set, that is a process that has been designed to try to be representative, like diverse, etc., high quality, and that is like it's a whole. I think there is a whole research field around this thing.
Great,
So,
thanks.
like so he asked about like if one can ensure fairness without impacting utility and relevance for some groups of users, and I would say there are in some cases there are no trade-offs, but those are few cases. Like in practice, I would say that I've seen cases, like practical cases, where there are no trade-offs, like where you can improve the system, both like the relevance for all users, and you can increase the representation of some of the users of different groups, and it's because the proxy that you are using for relevance is wrong, right? But I will say in most cases that's not the case. In most cases, you have to give up on some utility for some users in order to achieve parity or equality along another direction. So I would say in most practical cases, it's not relevant.
Okay, there's also another question on the chat by Sukumal Pai.
Yes,
User
user preference goes against the notion of fairness.
Say something quickly.
Yeah, so this user preference goes against the notion of fairness, right? Yeah, so I would say that the thing that's happening here is that the information retrieval system is not just designed for the utility of the people issuing the searches anymore, right? And of course, yes, so you may have to go against the preferences of the person who issued the search. But now we are increasingly designing these information systems where the preferences of multiple actors have to be taken into account, including those being searched. And in that case, what you want is to provide maximum utility for everyone, right? So there is a nice framework for this, which is two-sided market. So you have producers and consumers, and you want your system to be fair to producers and fair to consumer, right? If you look for P fairness and C fairness, you will see these notions more explained. But it's more like your users are more, and the user preferences are that they have to be taken into account are the preferences of more people.
Okay, we are getting a lot of congratulations for your talk on the chat. So I would like to thank Carlos. If there's no other very quick questions, I think you can contact Carlos by email. So just a very quick information, Carlos. Is the next conference on fairness, accountability, and transparency will be organized next year?
Yeah, so there will be, thanks for the opportunity. So this is called, used to be called the FAT Start Conference. Now it's called FACT Conference. I copy pasted the link in the chat window. It will be organized in 2021. It's being organized by folks from University of Toronto and other organizations. It will be later than this year. So this year was in end of January. Next year, it will be perhaps end of May or something like that. But it will be organized and it will be online. It will be an online conference next year.
Okay, great, excellent, because I think it will be a great opportunity for whom wanted to address these interdisciplinarity problems and concepts. Thank you very much again, Carlos.